All right. So today, like I said, I've got hurricane coming, so I didn't want to cancel if I didn't have to. So I'm gonna go over joins, what they are, how they work. I got some queries we're gonna go over. Um, and then normally I would take some time after this class to design a database, but we'll do that next week in the aftermath. Maybe I'll do a database on hurricane supply lists or something. That'd be kind of fun. Um, okay. Let me share my screen. I want to just do the entire. Okay. Okay. So you can go down here, and then you can go away. All right. Let's go to here. So in week 4, if you go to your preparation and reading, it's just about how to do cross joins, inner joins, the simple things, and we're going to talk about unions and accepts. So we're not going to do a ton of queries tonight, but we're going to talk about how joins work and why they work and the different kinds of joins that there are. And then we'll be doing join videos. We'll be doing join queries from now until the end of the course. You've got a video to watch in this one for the basic joins for that. Got a couple things here. And in this week's announcement, I made a video on joins back like 8 years ago. And I did like a deep dive into how joins work. So if you've got some free time, or you have insomnia and need to fall asleep, crack open that video and give it a look. Exercise are the exercises. The quiz is the quiz. And the paper is going to be what is the prompt for this week. If you are not doing the final project, the prompt for this week is clearly what you learned about mastering line. You must give you new tasks. You should qualify what you learned about redundant data in the context of equijoint statements. Oh, this is a horrible one. I got to change this one. Okay. If you are doing this and not the final project, just tell me a story about something. This I don't like. I keep meaning to change this one. Self joins are let's get into the code. I'll talk about self joins there because I understand why they want to talk about them, but self joins are problematic for a number of reasons. So let me just get into the code. Okay, so I also want this here.
Isn't it self join where you join the same table twice?
You
Like
so
it has
you
multiple
join the table to
keywords.
itself.
Yeah, I don't understand that one, so I
I,
haven't looked.
I I've got a example as to why you would do it. Um, I've got a silly example and I've got a rational example, and I'll probably use the silly example with Pokemon. Um, so I want MS Paint. Yeah. All right. So back in the second grade, we learned about Venn diagrams. At least I did. Did y'all? I probably got like 20 years on y'all. So we did Venn diagrams back in 74. So Venn diagrams is just two circles like this representing two different sets. And this is set A, and this is set B. And in here is the intersection of set A and B. That's the symbol. I don't know if y'all know the symbol. That's the symbol for intersection. So that's the intersection between A and B. All of this together is the union between A and B. Okay. So if you use tables instead of circles, you have table A and table B. This area here is here's the different kinds of joins. Um, okay, you've got your cross join. Never use cross join. It's a Cartesian join and it does ridiculous things. And I'll show you what it does in a second. Then you just have your inner join and you get your outer joins. And outer joins come in three flavors: right outer join, left outer join, and full outer join. And I'll asterisk that one because full outer joins are not available in MySQL. They do not exist in MySQL. Cross, inner, right, and left exist in MySQL. So for a cross join, how do I want to explain this? So if we have a table, and in that table I've got where's my where? So I've got this table. Okay, I should draw me a table, please. Okay. So I've got this table. And in there I've got the values of purple. I've got pink. I've got green. I've got lavender. I've got yellow. And I have another table. That's not a table. I have another table here. And in here are the values of glass, wool, terracotta. Any guesses who I was playing before we joined with you tonight?
I was gonna say
Concrete,
Catan.
huh?
Settlers of Catan, is that what that or
No, this is actually
oh
Minecraft.
Minecraft. Yeah,
Minecraft. Concrete.
yeah.
Um okay, so that's fine. Okay, so when I do a Cartesian join or a cross join, what's going to happen is it's going to take the first row of the table that's first listed and match it to every row in the second table. So if I did a cross join of these two tables, my result would be purple glass. Okay. And then the next one would be pink, glass, wool, terracotta, and then green. So what it does, it just, for some reason, someone thought it was a cool idea to do this. It just returns this paired up with everything, this paired up with everything, this paired up with everything, this paired up with it. So which means this eventually gets paired up with everything. This gets paired up with everything, just not in any kind of interesting order. Um, so that's what a cross join is. Um, I don't have any rational reason to ever use a cross join. It doesn't make sense to me. I don't get them. So I'm required by law to talk about them, and I'm now done talking about them. The inner join is the data where the two circles intersect, which is there, or the two tables intersect. So when you're doing an inner join, it returns any value that's in both tables A and B. And it is decided by a column that you name, and it will join the tables on that column and bring in any values for both tables where the values are equal. And I'll show you that. Well, I'll show you those in a second how they work. Outer joins, there's right and left. So when you're doing right and left table, right and left, you write your query like this. Actor. Wow, that's a sad color. Actor has A. Actor A. Inner join. Dylan is
On
B. B on A dot actor ID equals B dot actor ID. Okay. So I've got actor and I'm joining it to film and I'm doing it on the actor ID column. A couple of things. First of all, These columns don't have to have the same name as long as they have the same information. So maybe in your film table, it's called Union I. Maybe under actor table, it's called Union ID, and then in films, it's called Actor ID or whatever it is. They don't have to be the same name. They just have this. They have to have the same data type, and it makes sense if they have matching values. Okay. They also don't have to be keyed. And we'll talk about that more later, but the columns in the on statement for a join do not have to be foreign keyed to each other. It just makes it easier and better. You'll see I did actor A and film B. Those are aliases. Okay. When you are writing these queries, whenever you reference a column, you've got to designate what table that column comes from, especially if the two tables have the same column name. So if I just did this on actor ID equals actor ID, I would get an error saying ambiguous column name because both the tables have the same name, same column name. Now, if you were joining on a column that had different names between the two, you wouldn't necessarily have to alias it, but I always recommend to do the alias because it's just cleaner code. Okay.
So
You
when we're
also
doing
know,
so when you do the select statement in the last semester we took, they said we only have to do the table alias if the column name is the same. You're saying it's a best practice to use the table alias anyway,
yeah, it is.
regardless? Okay.
It's one of those things where having been in field for 25 years and having to deal with other people's code,
Gotcha.
um,
Okay.
it is a best practice to have the alias there.
Okay.
Because odds are on your inner join, um, the column names are gonna be the same. But if I have a select statement here, right, and I've got my select a dot name, b dot name, b dot rating, right? Oh, that's not fun. B dot rating, right? And I've got this my select statement. Both tables have a column called name, so I have to specify which one is going to be which. All right. I'm pretty sure actor doesn't have a rating in it, right? But by putting the alias there, when this code goes into the wild and someone looks at it, they don't have to think about where the column are. They just match it up. And when you're looking at this particular example, film and table, it's obvious that rating is not to do with actor.
Okay.
But if you
But
had
so you're just so in the wild when I've got 180 tables and I don't know the schema and I'm working on another project and somebody's on vacation and I just need to step in. That's okay. Golden
yep,
rule. Do
yep,
unto others as you would have them do unto you.
yeah,
Okay.
yeah. Because when you step in and see someone else's code, you're probably gonna want to pour lemon juice in your eyes. I've got these. So there's this at my work. There's two databases that have been around for 40 some odd years, and they started writing the code back in 82, 84. And what ends up happening is whenever code needs to be altered, the best practice when you have to make changes to code is to redo the entire statement. Because that gives you a chance to look at it, make sure it's done the right way, modernize it. New commands come out all the time. It's just a chance to optimize that code every time. That's not what everyone does. What everyone does is they just add lines to the end. So if the initial code was 25 lines, then Bob in 87 has to make a change to it. He just has another 12 lines to the bottom. And then Gina has to make a change in 89 and she adds 15 lines to the bottom. As opposed to that. And eventually, after 40 years, you've got a stored procedure that's 1,600 lines. Um, and if you guys, I don't know if Jason, you took the intro class last semester or not. You did. So you
I
guys know what triggers are, right?
yeah.
You know what a trigger is? Yeah. Okay. So triggers should be at most like 3 or 4 lines, one thing done fast, right? these databases I deal with at work have triggers that are 1,400 lines long. So I refer to those as sedimentary code because just crap gets added onto the end of it all the time, right? So it just gets built up, built up, built up. And at a point in time, you can't fix the code because there's just too much. It's just keep adding on to it. There's a breaking point. So anyway, so yeah, so you want to write the code so the next person behind you can read it and understand it. Because, and here's another thing, just I'm on sidebarring. This world in IT is extremely small. You wouldn't think it is, but it's extremely small. And people talk about other people all the time. And if you are writing bad code for the right company, if you're writing bad code for a company that's well known and it's got DBAs there who talk to other DBAs, your name is going to come up. And if you try to change jobs, they're going to know who you are. And I can tell you this happens because I've interviewed people who I've heard about and their bad practices. And what I have done in those interviews is I ask them about it to see if they're still doing it. So there is it's not an industry standard, it's just a understanding. It's like a gentleman's understanding. This is how we do it. So you can read it. So anyway, so the intro is this. So when I'm dealing with right and left outer joins, this is the table on the right. This is the table on the left. The first table is the right table. The second table is the left table. So if this were a right inner join, if I actor A right inner join, it'd be everything in the actor column, in the actor table, plus whatever is here. Okay. So that is my right inner join. My left inner join is anything in the film table along with anything that's common between the two of them. Okay. Now, here's the interesting thing. So when you run this, right, and I'll show you examples of this later, just kind of around it. When you run this, you're going to start seeing nulls show up. And what a null means is that there's a value in the one table, but there's no value in the other table. So yeah, so that's what we got. So that's the thing. So we know these nulls are going to start showing up. So we know where that's. Now, a full outer join is when everything comes back. So it is a left outer join plus the right outer join returned at the same time.
Don't you have to use a union in MySQL to make that happen?
Yes, that's what a union does in MySQL.
Okay.
The difference is so with union sort of does that. Union is a sledgehammer way to do this because it's not very elegant. And I'll show you that. I'll show you a union in a second. Okay, so that's what that is. So that's how this goes. So let's look at some code here. So here I've got two queries. I got select first name, last name from actor, and I got first, last name for customer union. Okay. So if I run this one, I get nothing because it didn't do what I wanted to do. So if I run this one, I get 200 rows return. If I do this one, I get 599 rows returned. When I run them together, it returns every row here. So 201 plus 599 is
800.
800, but I'm only going 797. Okay. So this returns everything, but nothing duplicate. So if the same thing exists in both tables, it only returns once. If I do union all,
get to 800.
Yeah, because it now counts the duplicates.
Isn't the use case for that one where you're trying to purposely find data integrity issues or things of that nature?
There's a couple ways this would be used. One is data integrity issues to compare two tables. The other way, and this is the one I've seen done mostly, is I'm merging two databases for two different companies.
Mm,
So if I owned if I own Don's bookstore and you own Mark's bookstore and you own Jason's bookstore and we're gonna combine it into JMD Books, right? And our databases have basically the same schema. A fast and dirty approach is just to run unions on our customer tables into one table. So it's going to give us all our customers except the duplicate ones.
would you store that as a view? Is that the best way to do that, or
If that's it, so that's a good question. So that's it. Like I don't know if I told you this last week, but all these questions always start with it depends.
okay. Yeah, you
Okay.
mentioned that.
So it depends. Are we merging the databases into one database, or are we keeping three separate databases for so and when you look so in terms of business, let's say I'm Don's bookstore is I'm a big multi-million dollar bookstore and you guys are like mom and pop shops doing great business in your towns and I buy you guys, right? I have a choice. I can either integrate you into Don's bookstore or I can let you be your own little subsidies and be associated with me for purchasing power. Also, it would allow me to sell you guys off if I wanted to. So that's just a corporate decision. If we're going to merge everyone into one giant company, all the databases we merge together.
Okay.
And we have some setting in the table that says what books are there, what's there they're originally a customer from. But if we're going to keep things separate, whatever keeps separate, we join it in a view as opposed to using the actual table. So, but yeah, for the most part, that's where I've seen this done is when if you need a fast, nerdy way to merge databases that are similar. So if I run this when I put the little customer thing there, so I can see where
What database are from? Okay.
yeah, what database from. So I can do so yeah. So now with this statement, the order by has to go at the end. Okay. Now, here's the problem with well, here's another union. Oh, this one tells you which one it is. So this one I'm doing union where last name equals Davis. I have two. If I do union all, there's the missing ones. That's why it's 300 then.
Mm,
Okay. Now, the thing about union is if I look at the customer table right there, and those are my columns. That's going to return because Union doesn't care what it is. All Union cares about is that the same amount of columns are there. So instead of first name, last name in both of them, I did first name, last name in actor and first name, email in customer. And it still gave me the values because it doesn't care. Joins care. Union just does everything. Okay. Does that make sense? Yeah. So again, it's a fast and dirty way to do things. It's very flawed. It's got its good points and its bad points. It's not made for any finesse. It's just a fast way to do it when you don't feel like doing a join. Now here, let's look at this quick join statement before we get to that other thing.
what was that accept thing?
We're gonna get to that in a second. Except is a command that didn't exist in MySQL until 2 years ago, but it's been on the quiz and in the book for the last 7 years.
Oh, jeez.
They finally added it. So here's a standard join. And it's a little more complicated because it's three tables, right? So I'm getting the actor's last name and the film title and the film rating. And I've got two tables that I know of. I've got last name. I'm doing actor as A. I'm doing title as F, and I'm getting rating as F here. Now, If I look at the actor table and I look at the columns, I see actor ID or a last name. There we are. Um, I see actor ID because that's what's being joined on. If I go into film, I don't have an actor ID here because when we look at normalization, actor doesn't belong in the film table because it's a many to many relationship because there are many actors in one film and one actor does many films if they've got a decent career ahead of them, right? So we have to do a table. We have to do a combining table. In this case, it's called film actor. If I look at film actor, it's got two columns: actor ID, film ID, and the last time it was updated. So in order to get last name to match to title,
You got to go
I've
through.
got to I've got to go through film actor. So here I'm matching actor as A. I'm interjoining it to film actor on actor ID equals actor ID. And then I'm taking this and interjoining it to film on film ID equals film ID. Okay. So this actually is a three-circle Venn diagram. And this is where I stop drawing Venn diagrams because it gets really confusing with all the circles. So again, I'm joining actor to filmed actor, getting that result, and then I'm taking this result and joining it to this. Now it's important to remember that because in some cases, the order in which you join the tables denotes the results you get back. It's kind of like order of operations in math, right? So 4 plus 5 uh, times 6 divided by 2, right? So we know it's multiplication, division.
Those
Um,
parentheses. Let's go.
it's
Ex
parentheses, multiplication,
exponents.
right? So I do this first, and then I do this, and then I add the plus 4, right? Um, if I did this and then that, I get the wrong answer, right? So the order of operations are very, very important. So when I'm doing joins, I kind of have to know what results I'm looking for. And sometimes you've got to be very careful the order you put the tables in. Because, like I said, this is the first thing that runs. And then this is joined to that. If the information you need is filtered out by this, then you got to figure it out and fix that problem. Okay. So, and we're going to talk a lot about joins. The accept command. This is kind of like the anti-intersection. So, there is no. So accept is give me all of these results except where these are the results.
So
So
in
this is
your
kind
example there,
it's
you
kind of
want
like
everything but NC-17 movies.
right, right. So here, this is going to return everything. But now I want you to filter everything out where it ratings NC-17.
So couldn't you do a where clause after that without the accept and then
Yep,
just say where it's not equal to, I just understand you're teaching the principle and the
yep.
point, but
Yeah, you can. Yeah, there's other ways to, but this is just a simplified way to show. There are cases where the accept makes sense.
okay.
For example, the through bookstores, right? So we've decided to keep we can access each other's databases, but we don't merge them, right? So I want to see what my sales were on my I want to see um what sales I had and what sales you had, but when they were unique sales, not the same people. So we got this guy, Tony, who shops all three of our stores. And we want to take Tony out of the equation.
Sure.
So I write a query that says except where Tony, and then I run this against all three tables or four tables, right? So that's where this except comes in. This is just a way. This also works with not in. I could do this and say not in and give that. and do the same thing. It's just a bunch of it's just another way to do the same thing. In coding, especially in SQL, there's generally 3 or 4 ways to do the same thing. The question is, so we talked about this last week. The difference is how the commands affects the execution plan. Except does horrible things to execution plans. So we tend not to use them. But it's been a question on the test for the last 7 years, and it's finally in the stupid thing. So that's what except does.
Okay.
It essentially does not in or a where clause modifier. Okay. So now, so when I run this, it just takes out the NC-17 movies. Okay. Does that make sense? Yeah. So except not in and where essentially all do the same thing. This one, well, where and not in are the same. Basically, use where and this is easier on the execution plan than this is.
So this is one of those things where if you've got millions and rows and tables and you could track how long it takes to execute each query and when from a if you've if cycles are important to you, you can figure out which one of these is the one to use after do some tests.
Well, yeah, and again, so yes, but let's say you're writing a query and you bring a bunch of information into temporary tables. Then the accept would make more sense because you've got these temporary tables there already. So it's you basically just play with it to get what you want. And then you test you write the query, see which way it runs faster. I don't know of anyone in the last 10 years that I've worked with that's used the accept clause. Most people use the where not ins or some other way of differentiating it out. Okay. So real quick about self joins. Okay. Okay, so here I need to add a column. And then I need to add a column here. So I'm going to go here. Where's my tables Pokemon? There we are. Go and add evolves from. Okay. So I don't know if y'all know about Pokemon. There we are. Okay. And it's going to be, this is going to be a int. Okay. So Pokemon evolve into other Pokemon. So here I've got Pokemon ID, the name of the Pokemon, the Pokédex value, description, if it evolves or not, and what it evolves from. Because it evolves from every Pokemon evolves from itself, I would literally do that. And I would foreign key the table to itself. That means nothing can go in here that's not here. Okay. But that's so you link a table, you self join a table to where PEMDAS, yeah, that's a blast from the past. You link a table to itself when it's got a column that is defined by something else in that same table. So for example, you have an employees table, and in that employees table you have uh manager, right? So the manager is an employee, so he's in that table, or there in that table. So that that manager column is going to point to the employee ID column
Of the same table.
of the same table. Now,
Okay.
you can do it. It's not the way you should, but it's a fast and dirty way. I've always liked doing that in a different table because then you can have when that person was added to the team, when that person was removed from the team, blah, 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 blah. But the reason why you join a table to itself is because there is a column in that table that will define that table. Manager to employee ID, Pokemon to evolve from. So you're using that main ID in that table in the second place. Is it a good thing? You can run into some sort of problems with it. I once did an example of for like a dog breeding business, and you had the parent, you had the puppy's ID, and then you had its foreign key to the parent's ID, right? And you couldn't put a puppy ID in until you had the parent's ID in there. But that caused a problem because you couldn't add the parents because that ID you'd have to add their parents in, and before you had those, you had this whole vicious circle down. You couldn't
Cycle
add
four times.
anyone until everything was there. So what we do in that case is we populate the database and then we add the key. So we put all the dogs in, put all the foreign key information there. So we put all the parents and all the puppies in. So everything is matched. And then we establish the foreign keys because the data is already there. And then you'll be able to make those foreign key matches without getting the error value's not there or value doesn't exist. It is a best as far as index. It is also best practice on the sidebar talking about indexes. If you're doing a bulk insert into a table of a couple of thousand rows, drop the indexes, input the data, and then reestablish the indexes. And I'll tell you why we do that now. And then in a couple weeks, I will have a 15-minute TED talk on why this happens. So whenever you have a table and it indexes itself, it's got this pristine index and it knows where everything is and it matches with everything. As time goes by and you delete things from the database and you add things to it, it doesn't rebuild that index. It just throws stuff on the bottom. So you have all this wonderful index, and then you've got this great recipe index, database, and you've got this table with recipes in it, and you've got this wonderful, the indexes match. It's based on recipe genre. And then you add like 100 new recipes, and those aren't indexed automatically. Those are sitting at the end, and they're not indexed into everything until you manually re-index the table. Um, so why did I get the tangent about indexes?
You're talking about doing bulk inserts.
Oh yeah, bulk inserts. So yeah, so what happens is if you have the indexes there while you bulk insert, it does it R bar and then has to add that column to the end of the index, which takes initial time. Um, if and then you have to defrag the index anyway. So if you drop the index, insert the data, and then add the index, it creates a brand new index. And it or sorts it out there so you're not defragmenting because there is an attrition to defragmentation on an index. The more you do, it's kind of like, your battery on your phone. The longer you use it, the less it charges, even though it says 100%. So my phone, I've had it for 2.5 years. It may charge to what back 2 years ago was like 85%, but it says 100%. So the more you defrag an index, the more the fragmentation stays there and you can't get rid of it until you drop and recreate the index. So there's that. Anyway, So that is the code for discussion tonight. Next week, we'll do a lot more about joins. We're gonna talk about full joins. We're gonna show you some examples for that. And then next week, I promise, unless the hurricane takes out my house, I'm living in a tent for a while, which I don't think is gonna happen. Next week, the last 20 minutes, we will design a database from the ground up. Okay.
So in your everyday professional life, which join do you use more frequently? Is the inner joins, is that where the
Inner
majority of the
joins.
time is spent?
Inner joins are 90% of the time what's used
Okay.
because you care more about what's in both tables, not what's missing in other tables. For data integrity, you use outer joins. For joining two database joining two databases that are from different companies, you'll outer join to see what's missing from them. But 90% of the time you're doing inner joins. And you can have one query that has left join and an inner join. You can do all the kinds of joins in there that you want. But again, the more joins you add, you can have. There used to be a limit to how many joins you could. I think it was like 27. You could join 27 tables in one query. I did it once on a bet, and it worked. I don't know if it gave the data it was supposed to do, but it gave data. But you generally want to only join as many tables as you need to get the queries. And if you're doing a query and you're joining your eighth table, you need to look at your database and see if the tables need to be normalized or something like that. Because if you're writing joins with 8 tables, the data isn't optimized. It's too much. Like my favorite example of this is when you're doing a customer like an address table, right? I saw one database, and this was a professional database. The guy did this. So generally speaking, you have your address, you get your city, state, and zip, right? So what a lot of people will do is they'll do the address, and in a separate table, they'll do city, state, zip. So like if you've ever noticed, if you're filling out something online and they ask for your zip code, you put the zip code in and it pulls everything up, pulls in city and state, right? So that's because that zip code, there's a table that has a city and state with it that attaches it to the address. There was one guy who I didn't work with him. He was in the same company I was. He was a developer for one of the financial apps, but he created a database where there was an address table, a city table, a state table, and a zip code table. And I'm like, why would you do this? Because A, it causes you to carry more space in your database than you need to. And B, you're doing 4 joins, which take 4 times as long as 2 joins. And we're talking microseconds in joins. So if I ran a join with a table with 4 columns, if a query with 4 tables versus 2 tables, you necessarily wouldn't see it. However, if 500 people are running the same query at the same time, you're definitely going to see performance issues. Okay. So that's why I say that designing databases is an art form because there's a nuance to it to understand how the data is coming in and out of the table and how you're going to make it come out and do what it needs to do with people and how you're going to make sure like the indexes are right and how the data flows, make sure all the tables are set up properly to not confuse the issue. So yeah. Don't like I said, if you're writing a query and you're on your eighth inner join statement, look at the table structure and see if it's right. Because I looked at that guy and I went to him because he sent his database to me because he was designing it for his application. And I turned around, I'm like, no, it's got to be one table. You can't do 3 tables. It doesn't make sense because of this. And I showed him the execution plans and whatnot. So he finally understood. Luckily, I do speak a little developer, so I was able to translate for him.
You told him it
But
works on your machine?
oh, yeah, it's like I hate when someone says it works on my machine. I hate when people say the internet is out because the world would stop.
Yeah.
The world would end if the internet went down. Um, There was a great TV show from a couple years ago. I forget what it was, but the premise was like overnight, everything electronic stopped working, and people went from the lifestyle there and now with internet and that to like nothing worked, and they have to like come back up. They learn blacksmithing. It was interesting. But whenever someone says the internet's out, I immediately think of that. So, um, there was a back in the infancy days of the day of the internet, someone realized that if you tacked the DNS servers for the internet for the cloud, you take down the internet. So they did. They did a DDoS attack on the DNS servers, and they took down 45% of active servers and connections, um, until they got smart and hid them. So anyway, many digressions tonight, but interesting stories. So do you guys get what I'm talking about? Are you picking up what I'm laying down?
So far, so good.
Sweet. So like I said, so next week, more joins. We're in week 5. I'll show you way more queries, I think, and then we will take at least 20 minutes and design a database from scratch. So you guys can see the process. Well, you can see my process. Everyone has a different process. I just talk to myself a lot and draw. So, all right.
Well, good
All
luck
right,
with the
John.
hurricane.
Thank you very much. I'm feeling pretty good, but you never know because these things get weird. Okay, take care. I'll see you next week.
All right.